and welcome to the presentation for Task 12, Learning from Disagreement. So I'm Massimo Poesio, but I'm presenting joint work with a number of people, in particular Alexandra Uma. Anybody who has been involved in an annotation project will know that when you ask people judgments about natural language or computer vision tasks, disagreements is rife. But most work in these fields is based on the assumption that it's possible at the end to somehow reconcile these different interpretations to produce a single gold interpretation. However, this assumption is being challenged more and more. There are many tasks for which and many items for which that is simply not possible. And so there's been a fair bit of research that tries to abandon this idealization. The objective of our shared task was to provide a unified testing framework, a benchmark that could be used to assess methods for learning from data that contain disagreements, both in natural language and in image classification. Our task, we identified 5 datasets from both the natural language and the computer vision fields, which have been already used in research on learning from disagreement, but also of a sufficient size that would allow to train state-of-the-art models, deep learning models. A second characteristic of the task is that we tried to employ both hard and soft evaluation. I will explain in a moment what that means. The task was run on CodaLab, so it is divided into standard trial and competition phase, and you can see the results there. Among the NLP datasets, we have 3 datasets. A part-of-speech tags dataset, the Gimpel dataset, which was originally annotated with code labels by Gimpel et al., and to which Planck et al. Added crowdsource labels. This dataset has been widely used in this type of research. A second dataset is a simplified version of the Phrase Detectives dataset collected through the game Phrase Detectives. Phrase Detectives corpus is of coreference, but for this task we used a simplified version, just a binary task, discourse new, discourse old. And finally, the corpus developed by Simpson et al. For studying humor, which consists of short texts, some of which are jokes, and some of them are non-jokes, and the annotators were asked to indicate which text was funnier. For vision, much research on learning from disagreement originated in vision, and so we used the 2 datasets which have been widely used in this literature. One is Label Me, that classifies outdoor images according to a number of categories. Rodriguez and Pereira added crowd annotations to this dataset to support their work on deep learning from crowds. And finally, CIFAR10 is also an image classification dataset, a larger dataset, and Peterson et al. Added to this dataset crowd annotations for 10,000 images, quite a lot of crowd annotations. So you can see in this table a summary of these datasets. All datasets contain at least 10,000 items, though Phrase Detectives almost 100,000. The number of annotators varies from around 50 for label me to more than 1,000 for phrase detective and cipher 10. Number of categories that we included both binary and multi-label tasks, and the number of annotations varies from, again, around 2 on average to over 50 for cipher 10. So we were trying to also ensure that it would be a bit of a variety of data sets in terms of their characteristics. As I was saying, we tried different types of evaluation. Even the work that abandons the assumption that it is possible to assign a gold label to each item often ends up evaluating models using what we call hard measures against silver aggregated or gold one hot label, such as using measures such as accuracy or F1. But we feel that this type of evaluation sort of begs the question, given that we are trying to abandon the assumption that such a gold label exists. So in our work, we've been trying a variety of what we call the soft ways of evaluating models. You're evaluating a model against a distribution, probability distribution of labels, what we call soft label. A simple way to do this is to use the cross entropy measure, which is standardly used in deep learning already and does not require the target label to be a one hot label. So we use this in previous work, and we use it also for this task. We wanted to encourage participants to focus on developing methods for learning from disagreement as opposed to concentrating on developing better models for the task. So we provided near state-of-the-art models for each of the tasks. For these models, we trained them using two different approaches for training from disagreement. Using hard labels aggregated using majority voting, and also training directly from the soft labels using the soft loss training method we proposed recently. So, coming to the competition. Well, unfortunately, even though more than 100 participants signed up to the competition and a healthy number of participants participated in the trial phase, in fact, only one group submitted a run for official evaluation from University of Reading. So this team focused on cipher 10 and more in general on vision, but submitted a run for every task. Specifically for cipher 10, University of Reading used the wide ResNet model, but adding a new sharpness-aware minimization optimization technique, which was developed specifically for training on noisy data. And for all other tasks, UofR used simple BERT models, fine-tuned for the task, but they used the deep learning from crowds approach proposed by Rodriguez and Pereira. This approach is a way of extending any model to train directly from the crowds by adding a crowd layer. Results. So you see the results here. In summary, we can see two main points. So first of all, for pretty much every task and every evaluation metric, we can see that using the soft loss training directly over the soft label, gives better results, both in terms of F1, in terms of cross entropy over training over the label aggregated using majority voting. We already found this result in previous work, but this was confirmed for this shared task. So this is in terms of the baseline models. In terms of the performance of the UFR team or the competitors, we see that for the CIFAR-10 dataset on which they concentrated, they managed to, the model that they developed is better than the models that we provided, both again in terms of hard evaluation and in terms of soft evaluation. Their model also performed quite well for label me, but not so well for the other datasets. Now, in our own research, we found that for these datasets, the deep learning from crowd method, which works actually quite well for CIFAR-10, did not work so well, but the performance achieved by the UFR was less than one would have expected, and we still try to understand why that was. And so coming to the conclusions, so even though our shared task was not successful, but the datasets and the Codalab page remain available to any groups interested in this area. So we hope that this collection of datasets can be useful as a sort of like first example of a benchmark of this type. The results suggest that learning, taking disagreement into account, besides being empirically more well-founded than simply assuming that hypothetical gold label can be found, can also be beneficial in terms of system performance. But more work is still needed to find good forms of evaluation. And those who are interested in this issue, we encourage to look at our presentation at the forthcoming workshop on benchmarking past, present, and future